All right, so in this lesson, we're gonna take a look at areas of trapezoids and areas of kites and rhombuses. So the area of a trapezoid, it looks really confusing, but it comes from the area of a rectangle formula. So if we had a rectangle, that would be base times height. And if we were to divide this so that this side and this side are the same, and then this side and this side are the same, we can see we create actually a trapezoid. So what happens is this particular length of the rectangle now, how do we figure out the length of it? Well, if I gave it numbers, if this was 4 and 3, we would know that the length is actually 7. But now what happens if I call it B and B, B1 and B2? Because we have two bases in a trapezoid, and those are the sides that are parallel by definition of it, right? And then the height, again, is gonna be the 90-degree angle. So how do we get this equation going on? Well, we said 4 plus 3 was 7 in the number example. So if I use letters, that 4 plus 3 becomes B1 plus B2. And since, again, we're only finding out half of the area of the rectangle, that's where the half comes from. And so that's how the formula can be created. Okay. Again, the height of the trapezoid is going to have a 90-degree angle, and we're going to see some examples where we need to use Pythagorean Theorem. So in this example here, identify the height, again, with the 90-degree angle, and then we're going to add the two bases together. So we add the two bases times the height divided by 2. And if you have the calculator, I recommend, if you use the ND button, you can type this in the end part and this in the bottom, and your answer will be given to you at 504. If you don't have this calculator, what I recommend you do is add those together, hit equals, times 18, hit equals, and then divide it by 2. So you'd have to do it in 3 steps if you don't have a fraction button that works like the one I recommend. Okay. So find the area of this. So we have the two bases, but what we don't have is the height. And so what happens is we have to create a 90-degree angle. So if this is 11, we know this part has to be 11, but the whole thing is 16, which means this is going to be 5, okay? So how do we find this then? Well, now we have a right triangle here, and we notice we are missing a leg. So if we're missing a leg, we're gonna subtract, okay? And so what ends up happening, traditionally this would be the Pythagorean Theorem where we set it up, we square, we subtract, and then we square root the answer. The shortcut way I explained in the lesson video would be 13 squared minus 5 squared, and that would take you immediately to that answer of 12. Okay, so again, you're looking for the 3 parts of the equation, the two bases and the height. And if you don't have the height, you're gonna have to do Pythagorean Theorem. All right, so now let's take a look at kite and rhombus. So now the kite and rhombus is the lengths of the diagonals multiplied together divided by 2. So we need the whole length. And we know, like in a rhombus, for example, the diagonals are bisected, and they also intersect at 90-degree angles. In a kite, only one diagonal is bisected, and that's the one that is not the symmetrical diagonal. The symmetrical diagonal breaks the kite up into 2 congruent parts. And again, the diagonals of a kite intersect perpendicularly. So we know that we're gonna have some right triangles. Okay, so in this example, it's pretty straightforward, where we have this diagonal, which is 1 plus 4, times 3 times 3, right? So here's our lengths to diagonal, so 5 times 9 divided by 2 is, 5 plus 6 divided by 2 is equal to 15. All right, so now here's a rhombus, and they only give you one diagonal, so we need the second. And so we said a second ago that the diagonals bisect each other. So this diagonal here is gonna be 12. This diagonal here is 13, and they meet at a right angle. And so what we end up having is a right triangle. Okay, so that's 12, that's 13. And so if we set up our shortcut, because we're missing a leg, we would do our subtraction, and that would get you an answer of 5. So now we're not done. That only tells us this part here is 5. And so this part here is 5 because the diagonals are bisected. And so now we have a length of 10, right? And we have a length of 24, the original diagonal, and then the one we calculated. and we would get an area of 120.